So previously, we have learned that the following operations here produces equivalent systems of linear equations. We can either interchange two equations. For example, we're going to rewrite this equation here on top, while this equation here at the bottom. We can multiply an equation by a non-zero constant. Say we multiply this by 1/2 or by 2, and we multiply a or add rather a multiple of an equation to another equation, such as we can add -2 of equation 2, or we can multiply rather -2 to equation 2, then add it to equation 3. So these are possible. So these are also possible in matrices, and in matrices they have a specific name, and we call them elementary row operation. So an elementary row operation on an augmented matrix produces a new augmented matrix corresponding to a new but equivalent system of linear equations. So first, let's write this system as an augmented matrix. So let's say we have matrix A containing the elements, the coefficient here is 1, so I'll write 1. This is -4, this is 3, and that is 5. Then this is -1, 3, -1, -3. This is 2. Y is not here, so I'm going to write 0. Then I'll have -4. Then I will have 6. There you go. So this is our augmented matrix of the given system. And if we do an elementary row operation on this matrix, we're going to get an equivalent augmented matrix rather of an equivalent system of linear equations. But since we're dealing with a matrix, we're not dealing anymore with an equation, but with a row. So the elementary row operations are as follows. We interchange two rows, not anymore equations because we're using a matrix. We multiply a row by a non-zero constant and add a multiple of a row to another row. So instead of equations, we are going to use rows. So let us demonstrate the elementary row operations. So let us perform the indicated elementary row operations on the following. So the first one says interchange the first and second row. So usually we have to write the operation first for easy remembering. So we are asked to interchange the first row and the second row. So I'm going to write R1, then a double head arrow, row 2. Which would indicate that in the matrix that I'm going to write, I'm going to interchange the first row and the second row. So I will write row 2 first. -1, 2, 0, 3. Then my previous first row, 0, 1, 3, 4. Then finally the third row that I did not touch, 5, -2, 4, and 1. And there you go. We already have our operation of interchanging row 1 and row 2. So, it's your turn. Do the elementary row operations of the second and the third one. Pause the video and perform the operation. Alright, so here we are asked to multiply the first row by 1/2 to produce a new first row. So we have to multiply 1/2 to produce a new row 1. Oops, let's write it more properly. There you go. So we are asked to have a new first row, a new row 1. As you can see, I would usually write R1 to indicate row 1. To have a new row 1, I need to multiply 1/2 to the old row 1. So therefore, I need to multiply 1/2 to each of these entries. So 1/2 times 2 is 1. 1/2 times -4 is -2. 1/2 times 6 is 3. 1/2 times -2 is -1. While the rest, I just need to copy. There you go. And here is our new matrix. But again, these are equivalent and so are these because we perform elementary row operations. They make the matrices equivalent. So the third one, we are asked to add -2 times the first row to the third row, and that produces a new third row. So our new third row is -2 times row 1 and then add it to the third row. So let's just bring this up a little bit so we will have more space. There you go. So therefore, we shall now have the following. Our row 3. So that means I can write row 1 and row 2 as is. Oops. Let's fix that. Maybe we can write it here already on this space here beyond the slide. Alright. So now, let's first copy the first two rows because anyway, we're not going to touch them. 0, 3, -2, -1. Alright, so we need to multiply -2 to row 1, then add to the third row. So that would mean -2 times 1, that is -2. -2 plus 2 is 0. -2 times 2 is -4. Plus 1 is -3. -2 times -4 is +8. Plus 5, that is 13. -2 times -3. 3 rather. -2 times +3 is -6. Plus -2 is -8. So there you go. Alright, so we now have a new matrix, but since we perform a row operation, they are equivalent. Alright, so these elementary row operations provide us the operations that we would need to solve our system in augmented matrix form. However, we still need one more thing, and that is how do we now turn augmented matrix like this into row echelon form? Because if you remember in Gaussian elimination, this was the goal, to make the system into row echelon form. We're going to learn row echelon form in the next video.